In this section 1.6, factoring polynomial, we will look at the GCF or the greatest common factor, factoring by grouping, factoring expression containing non-integer rational expression, factoring trinomial, and factoring special binomials. The definition of the factoring. Factoring is the reverse process of multiplication in order to find two or more expressions whose product is the original expression. A polynomial with integer coefficient is factorable if it can be written as a product of two or more polynomials, all of which also have integer coefficient. If not factorable, the polynomial is called irreducible, or we call the prime polynomial. The goal of factoring a polynomial is to completely factor or to write it as a product of prime polynomials. This means no factors can be factored any further. The GCF, or the greatest common factor among all the terms, is the product of all the factors common to each. For example 1, we are going to factor the following polynomials by factoring out the greatest common factor, or the GCF. If it cannot be factored, we indicate not factorable. In part A, we have three terms for this expression: 9y to the 7 minus 27y to the second minus 3 times y to the third. We look for the GCF of these three terms. So on the side notes, to find the GCF, or the greatest common factor, which is the product of all the factors in common to each. For the number part, or the coefficient part, we have 9, negative 27, and negative 3. The common factor among these would be the factor 3. And for the variable parts, so we have variable y to the 7, y to the second, and y to the third. The common factor among these three terms gonna be y to the second power, or the lowest exponent. Therefore, the GCF for this expression is 3 times y squared. Or another way you can figure it out would be like breaking up the 9, 27, and 3 to see the common factors. So 9 is 3 times 3, 27 is 9 times 3, and 3 is just 1 times 3. So then we have the common factor as the value 3. So we're going to take the 3 out as a common factor, and also y to the second as the lowest power. Therefore, y to the 7 means y to the fifth times y to the second. Y to the second means y to the 0 times y to the second. And the last one, y to the third, means y to the first times y to the second. Since y to the second is the common factor to all, we get it out to join with the 3. So 3y to the second. So in parentheses, since we already take the 3 and y square out, the remaining factor for the first term gonna be just 3 times y to the fifth. And then the second term would be negative 9 times y to the 0. And y to the 0, technically it is 1. And the last term would be negative 1 times y to the first. And then we write it in a nicer form, would be 3y to the second times 3y to the fifth. If right in the descending order, going to be minus y minus 9. So now we are done. Factored, or this is the most simplified form of this expression. For part B, we have the expression 15x to the third times y plus 10 times x to the fourth minus 20 times x to the third times y. We have three parts for each term. The number part, the first term is 15, second term is 10, and the third term is negative 20. And then the x variable, the x to the third, x to the fourth and x to the third. And for the y, we have y to the first or just y. The second term, no y, that means y to the 0 power. The last term is y to the first. And then we look at the lowest factor as a common to all of them. So 15, 10, and 20, negative 20, the common factor would be the value 5. And for x to the third, x to the fourth, x to the third, we look at the lowest power, which is x to the third. And then for the y, the lowest power would be y to the 0 or just 1. Therefore, the GCF for this expression going to be 5 times x to the third. Then for the expression, we just rewrite it as the product of the GCF and the remaining factor. So 15 would be 5 times 3, x to the third as x to the third, and then times y to the first. For the 10, it's going to be 5 times 2, x to the fourth is going to be x to the third times x to the first. The negative 20 would be negative 5 times 4 times x to the third, and then times y. And then we just factor out 5 and x to the third, 5 and x to the third, 5 and x to the third from each term. So we get the GCF 5 x to the third, and then parentheses, the remaining factor of the first term would be 3 times y. The second term would be 2 times x. The last term would be negative 4 times y. And since we have 3y and negative 4y as like terms, so we can combine these two to be negative 1 times y, or just negative y because we combine the coefficient, or 3 minus 4 equals negative 1. Therefore, the most simplified form for this expression would be 5 times x to the third multiplied by negative y plus 2x, or write it as 5x to the third times 2x minus y, either one. In part C, we have the expression in the form of the power 2 of the quantity x plus y subtracted by 3 times the quantity x plus y. As we notice, both terms, two terms, they have the common factor x plus y and x plus y. But to make it more manageable, we just rewrite the power 2 of the first term as the product of the same quantity. So the power 2 of x plus y is the same as the product of the x plus y and x plus y, and is subtracted by 3 times x plus y. And with this way, we can identify the common factor, or the GCF. So we put a note here, the GCF for this example gonna be the quantity x plus y in the parentheses. So we factor the GCF out of these two terms. Then be x plus y, and then the remainder factor gonna be x plus y in the other parentheses subtracted by 3. So now we have the simplified expression for part C.